In this video, we're going to look at solving linear inequations. Now, this process is almost exactly the same as the one in our previous video when we solved linear equations. However, we now have these inequality symbols involved. And that turns equations into inequations. And it means that we have often more than one solution. And it means that there's one extra step that we need to follow whenever we multiply or divide by a negative value. So let's look at how inequalities work to begin with. What I'd like you to do is pause the video just to have a look at this table and read what's going on. Here we're talking about the different symbols that could be used for inequalities, what their meaning is, and some examples. So pause the video now and have a look at what that is, and then we'll get to the true or false questions next. All right, so now we're going to look at these true or false questions. The first one, is it true that 2 is less than 3? Well, yeah, that makes sense. So that's true. So I'm going to put a tick next to that one. Now, is -2 greater than or equal to 3? Well, negatives aren't bigger than positives. They're smaller. So a -2 is actually smaller than 3. So that one's false. Now, is it true that 2 is not equal to 3? Well, yeah, they're not the same. So yeah, that is true. And so that's a basic overview of how these inequalities work. Next, we're going to look at solving some problems that involve inequalities. So this first one here is a problem that we have solved before, except it was an equation then. Now, because we're using an inequality sign, this one is a less than sign, we're going to call it an inequation. Now, inequations are solved in almost exactly the same way. The first exception to that is that our final answer is actually going to be a range of solutions. So let's look at an example of that in this one, 2x plus 4 is less than 18. Now this is solved almost exactly the same way, so that means I can subtract 4 from both sides. And I get, if you like, you can cancel that out, we get 2x. I keep the inequality symbol exactly where it is from before, and that's 14. And then I'm going to divide both sides by 2. And so I'm left with x is less than 7. So notice here that I actually have a range of solutions. In fact, any value that is less than 7 will work. So 6, 5, 0, -7, all of those are valid solutions, even decimals, so 0.5 or -7.6. All of those are valid solutions. There's actually infinitely many values that solve this problem, not just one. However, 7 is not actually a solution. So if I was to describe this on a number line, I'd put a circle there to show that 7 is not a solution. Otherwise, I'd fill it in to show that 7 was a solution. So it's just a circle around it, and then all of these values over here are considered valid solutions. Let's look at the second problem. Now, this is where our second exception comes in. Whenever you multiply or divide by a negative value, you reverse the direction of the inequality. So in this case, we will end up dividing or multiplying by a negative. So the direction will turn from that to that. So we still keep that little equal sign to show that it's less than or equal to below it, but we just reverse the sign direction. So actually the only thing we need to do to this problem is multiply or divide by -1. And if we do that, then we get rid of the negative symbol on both sides. So you can do either. In this case, I'm going to multiply by -1. So if I times by -1 and times by -1, then I get positive x on the left-hand side and positive 6 on the right-hand side. However, because I am multiplying or dividing by a negative value, I reverse the inequality. So that now looks like this. And that's my final solution. X is less than or equal to 6. So that means that it could be equal to 6. So I'm going to fill in that circle and any value less than it. So that's the really, really important thing you've got to remember when solving these problems. It's almost exactly the same, but when you multiply or divide by a negative, you reverse the direction. And that's it. Thanks for watching.